Hello everybody and welcome back. We're going to continue our look at the 2012 Manitoba Mathematics Competition. We're up to question number 5. Hopefully you've been giving them a try as we go along. And let's dive in. It's a two-parter question, A and B, just as the last one, and it looks like just as the next one. And then that sort of stops. But question 5 here, A part. Find the value of x for which square root x minus 1 and square root x plus 1 are reciprocals. So root x minus 1, root x plus 1, we've got to have them be reciprocals. Well, set up an equation. So if they are reciprocals, well, what does it mean to be reciprocals? 1 over 1 has got to be the other. There's no particular reason I can see to do 1 over 1 versus 1 over the other, so I'm just going to say 1 over root x plus 1 is the same as root x minus 1. Or another way to write this, your reciprocals if your product is 1. So you could get that from this first equation just by multiplying by root x plus 1 on both sides, but 1 is root x plus 1 and root x minus 1. Okay? Now, it's not that hard to expand this out, but for those of you who've seen something called difference of squares, a plus b and a minus b is a squared minus b squared. This is a great thing to know. It's helpful to go both ways. In this case, it's really quick to expand. You get minus 1. So root x squared minus 1, or really just x minus 1. Okay. Well, it's not that hard from this point to see. So rearranging, we see x. Just bring the other one over to the other side. X has got to be 2. Okay. Now, were we asked for specifically x, or were we asked for those two values right there? Find the value of x for which those are reciprocals. Fantastic. Okay, so we've got it. Now, we're not allowed calculators, so we couldn't grab it and check it, but this really does work. Root 2 plus 1 and root 2 minus 1. At least it makes sense, because root 2 minus 1 is, root 2 is just a little over 1. It's about 1.4. So root 2 minus 1 is less than 1. Root 2 plus 1 is greater than 1. And that should be the relationship. If they're reciprocals, one's bigger than 1, one's smaller than 1. One's between 0 and 1, that is. All right, so x equal to 2. I'd put a little box around it, but we've justified everything that's going on here. Okay, and now B part. Prove that there is no real value of x for which x and 1 minus 2x are reciprocals. So what we're going to do here is a proof by contradiction. We're going to assume that there is a pair. There is a value of x so that this pair is reciprocals, and show that that is nonsense. So I might start by saying, suppose, if you want to tell them where you're going, you want to sort of telegraph what you're doing, you might say, suppose, toward a contradiction, suppose toward a contradiction. Just gives them a little heads up as, oh, we're doing proof by contradiction to show that this doesn't work. It's not as critical on, say, a math contest, because there's only so many ways you would be approaching a question like this. This is more just general math etiquette in case you go on and eventually do math research, write math essays in university, any of that sort of stuff. It's a good idea to let your readers know what's going on, especially if the readers have no idea what is going on. Whereas a marker for this sort of thing is going to be briefed on the different ways to do a question. I always say, suppose, towards a contradiction, that there is such an x. Then it satisfies, well, what do we have? We've got, what were the numbers? X and 1 minus 2x, they've got to be reciprocals. Well, then their product has to be 1. So it satisfies 1, x, and 1 minus 2x. Well, really, that's just x minus 2x squared. And I'm going to rearrange this to just a quadratic. We're going to bring everything over to the other side. So 2x squared minus x plus 1 equals 0. So by the quadratic formula, we see, well, x is going to be what? Negative b plus or minus the square root of b squared, so negative 1 squared, minus 4, a is 1, or sorry, a is 2, c is 1, so 4ac, all over 2 times a, which is 4. That's 1 plus or minus, this is going to be 1 minus 8, and there's our problem. You get a negative 7 here. That means that, well, you can't take the square root of a negative number. You get an imaginary number. You get a complex number. So since they are asking in the question, just remember, there are values of x that would make this work. However, they're asking for no real value of x. So since this isn't a real, since these aren't real values of x, we've got a problem. Again, you could say something fancy like, since the discriminant, the part under the square root sign, since the discriminant is negative, x cannot be real. So we've concluded, so thus no real value of x makes x and 1 minus 2x reciprocals. Now we've justified it, we've showed what's going on. Alternatively, you could make a comment that these values of x are not real, they are complex. That would be perfectly fine, but we've identified the problem. They want real x's. We can't get a real x. The equations, the formulas, what must be satisfied leads us to non-real x's. That is the crux of what's going on here in 5b. Not a bad question. I think it was nice and sweet. I'll see you guys for question number 6 in the next video. Take care.